An estimated 1.4 million bananas are thrown away every day around the world because they start browning. If the ripening process of bananas can be slowed, then this waste can be prevented, saving money and making the environment cleaner. Bananas and other fruits and vegetables, including tomatoes, avocados, and apples, produce a chemical called ethylene gas. When these fruits are ready to start their ripening process, there's a surge in their production of ethylene gas. Some online sources say that if an area is too windy, much of the ethylene is blown away. This would slow down the ripening process of bananas because there is less ethylene present. Our statistical question is, does creating a flow of air on banana with a fan significantly increase the time it takes to ripen? We obtained 60 bananas from Vaughn's and randomly assigned them to two groups. One was the control group and one was the fan group. Two fans are placed facing the fan group, creating a path of air flowing through the bananas. We recorded the ripening process of the bananas using a time lapse, and then afterwards we went back through the time lapse and estimated the time it took each banana to ripen. We considered the bananas ripe when the first spots started to appear.
Looking at the data, the mean ripening time for the treatment group was 105 hours, approximately 0.833 hours more than the control group's mean ripening time of 104.167. The treatment group standard deviation was also larger, 28.989 hours compared to the control group standard deviation of 25.507. Both the sample distributions of the treatment groups and the control group were slightly skewed right. The treatment group's sample distribution has 5 outliers, 3 more than the control group, which has only 2 outliers. Analyzing the data to test whether the airflow actually affected the ripening rate of bananas, we assumed that the average time it takes for a banana to ripen in either the treatment or the control group was the same, but our alternate hypothesis was that the bananas in the treatment group ripened slower. To follow through with our examination and use a 2-sample t-test for difference in mean, we had to check that the necessary conditions were met. Both the control group and the treatment group were comprised of 30 randomly assigned bananas, meeting both random condition through random assignment and normal condition by satisfying central limit theorem. After completing a 2-sample t-test, we gained the test statistic of 0.118 and a p-value of 0.4534. Therefore, we didn't have sufficient evidence to reject the null at a 0.05 significance level and prove that airflow slowed down the ripening process.